The concept of life as a multistrata hierarchical emergence. Hierarchical emergence refers to the phenomenon where systems develop layered complexities, with emergent properties at one level forming the foundation for new properties at higher levels. That is emergence, which is formed of components that are themselves emergent properties based on the underlying components. Life as multistrata emergence captures the essence of complexity that arises from the sequential organization of simpler units into progressively more complex structures. At its core, this model illustrates that life is not merely a result of isolated components, but a manifestation of layered emergence, where each level builds on and transforms the properties of the previous one. Here, life becomes a continuum of complexity, with each level of organization imparting new properties and capabilities to the system as a whole. This structure can be conceptualized as a hierarchical cascade of emergence, where each stratum both enables and constrains the potential of the subsequent one, producing the phenomenon we recognize as life. Based on this concept, one rule is that each of the base components is essential but insufficient for the tertiary emergence. 1. The hierarchical cascade of emergence. Starting at the atomic level, atoms combine based on their electron configurations, forming molecules that possess properties beyond those of individual atoms. For instance, a single oxygen or hydrogen atom has characteristics unlike those of the water molecule they form when bonded. This bonding gives rise to new interactions, allowing molecules to interact and combine into compounds with unique chemical behaviors that enable complex reactions. When these compounds organize further, they create polymers, which bring stability, complexity, and the capacity for interaction on a larger scale. Polymers, such as proteins and nucleic acids, set the stage for cellular life as they establish self-sustaining reactions and regulatory functions essential for survival. Here, cells emerge as autonomous units, capable of metabolism, replication, and responsiveness to their environment, foundational qualities of life. Cells then organize into tissues that specialize and perform distinct roles, forming cooperative networks that generate functionality beyond any single cell. The process continues through organs and organ systems, each stratum building on the capacities of the previous, collectively contributing to a self-sustaining, adaptive system we define as life. 2. Properties. Emergent at each stratum. As we ascend through these strata, emergent properties unique to each level contribute to the complexity of life. Molecular level, chemical stability and reactivity. Compound level, complex reactions, structural integrity, and interaction potential. Polymeric level, information storage, catalysis, and dynamic regulation. Cellular level, metabolism, genetic continuity, and adaptability. Tissue level, division of labor and specialization. Organ level, coordinated function and regulation. Organ system level, integration and adaptability. In this way, each level unlocks new capabilities that contribute to the overall life process, introducing capacities that were inconceivable at the preceding level. Number 3, life as an emergent property of complexity and organization. This multi-strata perspective highlights that life is fundamentally a system property. It does not reside in any single atom, molecule, or cell, but emerges from their organization and interaction. Therefore, the life we observe in a multicellular organism is not the sum of its parts, but the result of layered interactions that enable phenomena such as consciousness, reproduction, and adaptation. From this viewpoint, life becomes an emergent phenomenon that cannot be reduced to any single stratum, but only fully understood as a consequence of this hierarchical organization. This conceptual framework also suggests that any disruption in the integrity of this cascade, such as cellular dysfunction, loss of tissue structure, or organ failure, has cascading effects that can compromise the entire system. Thus, life is a delicate balance of interactions across all strata, where each level depends on the stable functioning of the one below. 4. The evolutionary implications of emergent life. In evolutionary terms, each layer represents a stepwise adaptation that allowed life to develop increasing levels of complexity. Initially, molecules and compounds formed, driven by chemical laws, but as each level organized into more complex structures, selective pressures refined each stratum's function, resulting in highly adapted tissues, organs, and systems. This cascade thus also suggests that life evolves not only through genetic changes at the molecular level, but also through structural and organizational innovations at higher levels, each contributing to the organism's overall survival and adaptability. Life, therefore, can be seen as a dynamic continuum of complexity, an emergent property arising from the cooperative interaction of simple elements structured through evolutionary processes into the intricate adaptive systems we observe in biological organisms today.